Hey there, and welcome. Today, we're going to pull back the curtain on the hidden science that really makes our modern world tick: statistical quality control. Now, I know it sounds a little intimidating, but I promise you it all comes down to one simple but really powerful idea: consistency. I mean, really think about that for a second. When you grab a box of cereal or a can of soda, or even get in your car, you just expect it to be right every single time. But how on earth do companies pull that off? Not just once, but millions of times over. Well, it's not magic, it's math. For ages, the big players in manufacturing have been using the power of statistics to keep an eye on what they're doing, to hunt down problems, and just make sure that everything that leaves the factory is up to snuff. This isn't some new fad. It's a time-tested method that turns the messy, unpredictable real world of production into a science. All right, so here's our game plan. We're going to start with our cereal box problem, and then we'll get into the awesome charts that act as our guide. We'll see what happens when things go a little haywire, and then we'll look at the absolute gold standard of quality, something called Six Sigma. After that, we'll talk about a different problem: what do you do with parts you buy? And finally, we'll wrap it all up with why this whole consistency thing is so important. You know, every single process, I don't care if it's filling that cereal box or even just making your morning coffee, has a natural enemy. And that enemy is variation. The simple truth is, no two things are ever perfectly, exactly the same. So the whole quest for quality, it's really just a battle to understand and tame this variation. So here's how the experts think about it. They split variation into two types. First up, you've got common cause variation. This is just the natural, random static that's always there in any system. You know, tiny little shifts in temperature or humidity. It's just background noise. But then you have assignable cause variation. And this is a signal. It's telling you something specific has gone wrong. Maybe a machine part is wearing out, or someone used the wrong ingredient. That's the kind of variation you can actually find and fix. Okay, so if one type is just noise, and the other is a signal, how do you hear that signal over all the static? Well, you need a special kind of dashboard. And in the world of quality control, that dashboard is called a control chart. And that brings us to this big idea: Statistical Process Control, or SPC for short. Really, it's just a way of thinking that says, let's use data, not guesswork, to see what's happening. And the number one tool for the job is that control chart. It tells you in real time if your process is running smoothly or if something is starting to go sideways. And you know, what's great is how simple this chart really is. At its heart, it's just a graph over time with three really important lines. You've got the center line, which is your average, your target. Then you have an upper and a lower control limit. Think of these like the bumpers in a bowling lane. As long as your ball, your data points, stays in the lane between those bumpers, your process is considered in control. Okay, let's see this thing in action. We're going to go back to our cereal factory and watch the filling process. We're on the lookout for that signal, trying to spot it in all the noise. All right, here we go. Here's our chart. We take our first sample of boxes, find the average weight, and put a dot on the chart. Yep, it's right between the lines. Perfect. Sample 2, same thing. Looks good. Sample 3, sample 4, everything's looking nice and stable. This is what a healthy process looks like. This is just the normal, everyday noise. But hang on a second. Look at sample number 5. Whoa, it's dropped way down, completely outside the lower control limit. In the language of quality control, this process is now officially out of control. So what does that actually mean? Well, this is the crucial part. Out of control doesn't mean the factory's on fire. It's a precise statistical signal. It's the chart screaming at us that an assignable cause, specific problem, has almost definitely popped up. Maybe a filling nozzle got clogged. Who knows? The point is, the chart is telling us, hey, stop the line. Go figure out what's wrong now before you make thousands of cereal boxes that nobody will want. So keeping a process on track is one thing, but what if you could make a process so incredibly good, so consistent, that mistakes almost never even happen? Well, that's the quest for near perfection, and it's called Six Sigma. Six Sigma is this super intense, data-driven way of doing things that Motorola famously came up with back in the 80s. And they did it because they had to compete with the insane quality of Japanese products at the time. See, this isn't just about staying between the lines on a chart. This is about making your process so good that a defect is practically a historical event. So how perfect is almost perfect? Well, get ready for this, because it all comes down to one mind-bendingly small number: 3.4. Yep, you heard that right. A process that's running at a Six Sigma level of quality will only produce 3.4 defects for every 1 million chances it gets to make one. Just think about that. That's not just good, that's an absolutely incredible standard of excellence. And this image shows you exactly how they pull it off. By the way, sigma is just the fancy stats word for variation, how spread out your data is. So to get to Six Sigma, you basically do two things. First, you relentlessly attack variation to make your process super consistent. You can see that here as the bell curve gets really tall and skinny. And second, you make dead sure your process average is smack dab in the middle of your target. You do both of those things, and you get a process that almost never makes a mistake. So, up to now, we've been talking about controlling the quality of stuff you make. But that's only half the battle, right? What happens when you're the one buying parts from someone else? Just imagine a truck backs up to your factory and drops off a pallet with 10,000 computer chips. The big question is, are they any good? I mean, you can't possibly test every single chip. It would take forever and cost a fortune. So what do? How do you make a smart call? Well, the answer is a clever tool called acceptance sampling. And the logic, as you can see here, is actually pretty simple. You get a huge batch of items, you reach in and pull out a small, random sample, and you check just that sample. Then, based only on the quality of that tiny little handful, you make a huge decision. Either you accept the whole lot or you reject the whole thing. Now, of course, because you're not looking at everything, there's always a bit of a gamble. You've got what's called producer's risk. That's the risk that you just happen to get an unlucky bad sample and you end up rejecting a perfectly good batch. The producer's not going to be happy about that. On the flip side, you've got consumer's risk. That's where you get a lucky good sample and accidentally accept a bad batch. Now you're the one who's in trouble. The whole science of this is just finding the right way to balance those two risks. Okay, so from filling those cereal boxes to deciding on computer chips, we've seen how statistics gives us this incredible toolkit for managing quality. So let's just take a step back and bring it all home. So, what are the big things to remember from all this? First, variation is the enemy of quality, plain and simple. Our job is to understand it and shrink it. Second, control charts are our dashboard, our early warning system. They let us see what's happening right now. For those who want to be the best of the best, Six Sigma is the mountain to climb. And finally, when you're dealing with suppliers, acceptance sampling gives you a smart, scientific way to make the call. It all boils down to using data to be consistent. You know, this is such a powerful idea, and it goes way beyond the factory floor. Think about your daily commute to work, or the way you make your coffee, or even how you study for an exam. Just think for a second, where in your own life could a little less variation, a little more consistency make a really big difference? Something to chew on. Thanks so much for joining me.